you can dramatically lower your lactate production at any given aerobic level. Wouldn't it be a whole lot better to eliminate most of the lactate beforehand instead of training our bodies to get better at tolerating and clearing it? Increasing fat oxidation actually happens to play a big underlying role of lactate threshold training. Some of the aspects are built around adaptations for lactate tolerance and clearance to be able to handle more. Hi there. Today I'd like to talk about lactate, which is often referred to as lactic acid. Now, if you're a fairly serious athlete, you've heard about lactate or lactate load or lactic acid buildup, lactate threshold training. And this is around so you can adapt to build up that lactate threshold. And this is why lactate is a classic marker for fatigue, and entire strategies are built around lactate threshold training, while increasing fat oxidation actually happens to play a big underlying role of lactate threshold training. Some of the aspects are built around adaptations for lactate tolerance and clearance to be able to handle more. So my question for you today and in today's vlog is, why all this training and adaptation to increase lactate tolerance and clearance when it would be a whole lot better to minimize lactate from accumulating in the first place? In other words, wouldn't it be a whole lot better to eliminate most of the lactate beforehand instead of training our bodies to get better at tolerating and clearing it? That's what fat adaptation does. And nature, evolution shaped us over millions of years to be robust and perform at the highest levels precisely because our lives depended upon it. We evolved to metabolize fat as our aerobic energy source. And as the FASTER study demonstrated, by making this fundamental shift to fat as your fuel, we can dramatically reduce lactate load and accumulation. Now, our modern focus on carbohydrate-based energy has actually created the challenge of lactate clearance. Once again, by not looking to nature to guide us, our shortcuts have led to unintended consequences. We are not being efficient here. But let's not blame it on lactate. Lactate is a proxy for sugar burning. That is the real problem. Now, oxidative stress occurs all the time, but our bodies have pathways to deal with normal levels of oxidative stress, even during exercise. The oxidation of glucose is one of the biggest contributors of oxidative stress, especially in carbohydrate-dependent athletes. And poor old lactate gets the blame. Lactate is a byproduct of breaking down glucose into acetyl-CoA to feed into the Krebs/citric acid cycle to create energy. When glucose is cleaved into pyruvic acid and lactic acid, both are immediately buffered into pyruvate and lactate. The pyruvate is converted into acetyl-CoA and fed into the Krebs cycle to produce the energy, while lactate is shipped out of the cell into the bloodstream to be recycled or used. The proxy, lactate, tells us how much sugar we are burning, and the more sugar we burn, the more oxidative stress we are creating. So, on top of having to recycle lactate, the body has to deal with a lot of oxidative stress. On the other hand, long-chain fatty acids are inherently stable, they're full of energy, and create the least amount of oxidative stress as they are cleaved off into carbon units and converted to acetyl-CoA through a process called beta oxidation. Our mitochondria love them. So not only are you tapping into a sustainable supply of energy, but one that is the most efficient and does the least amount of damage. So, what I am positing here is the best way to increase your lactate threshold would be to focus on optimizing your fat metabolism, because you can dramatically lower your lactate production at any given aerobic level. Think about this. This is another reason why both VESPA and OFM are a true paradigm shift in health and performance. Thanks very much.